F, G, and H are differentiable functions of x. And differentiable basically means, of course, we can take the derivative. We never run into a situation like that, like absolute value. Of course, that's not a straight line over there, but whatever. And we are going to find an expression for the derivative of each of the following functions. So don't expect there to be some clear, definitive numerical answer, first of all. Second of all, there's going to be a lot of F's and G's or E's and H's. There's going to be a lot of just random stuff in there. The answers are going to look kind of funky and blurry, apparently, so this thing is not getting cleared up, and so you're just going to have to squint really hard. But what we're going to do first is identify the biggest thing happening other than the blurriness. And I look at this and I realize that I can't see it. No, it'll get in focus in a second. There it goes. Okay, the biggest thing happening is the product rule. All right, biggest thing happening is the product rule. So I'm going to go ahead and start by writing, you know what, we have a product rule. And my product rule is going to be f prime g plus f g prime. Now, taking the derivative of each of those is going to be a little trickier because that's going to involve other little things over on the side. It's going to be chain rule stuff. We're going to learn to do a few things in our head as well. But we're going to have f prime g plus f g prime. And you can call it f and g. You can call it whatever you want to call it. I'm going to go a little crazy here. I'm going to get real crazy. And instead of overusing f's and g's, I'm going to call them u's and v's. Totally okay. Like, what are you doing, Mr. Reader? Well, I'm changing it. I'm tired of using f's and g's because f's and g's will pop up here and then I'll be like, well, is this f really the same as that f? And I've double defined f and it's just so confusing. So let's not. So the product rule is going to be f prime g plus f g prime. Okay? U prime v plus uv prime. Totally okay. You can do that. So what I am going to do is go ahead and figure out everything I possibly can, and let's just go ahead and start writing some stuff. I'll write the answer in purple and then fill in some gaps around it. So u prime, oh, that's going to involve the derivative of this, and so u prime is, let's switch colors again. I need u prime, and in order to do that, that's going to be a chain rule issue. And so I'm going to do a little bit in my head. I really have u equaling f of 2x. So the derivative of u would be the chain rule, which is the outer function with the inner function intact, times the derivative of that inner function, which is just 2. Okay, great. We just found u prime, and we'll bring it back over here. U prime v, okay, well, don't change anything. E to the gx. E to the gx, okay. Plus u, oh, nothing changes. F of 2x. And then v prime, oh, looks like we're going to have to switch colors again. So I need v prime now, and v prime. Oops, let's just call it v first. You don't have to do that, but I'm going to. V is e to the g of x. And so v prime is going to involve the chain rule. And the biggest thing happening is that the e got raised to a power. So the derivative of e to whatever is e to the whatever times the derivative of this inner function. This inner function that's happening right here is g. So the derivative of that would be g prime. So the derivative of e to the g of x is e to the g of x times that exponent, which is g prime. So there we go. That comes back over here. And we have g prime of x, e to the g of x. And I think that we can leave our answer exactly like that. There's rearranging we could potentially do, but I see no purpose in any of that. It's in a very socially acceptable mathematical order, or mathematically acceptable order. Okay. Number 6 is where things start to get really crazy, and this is what I call the super chain rule. This is a chain rule and a chain rule, and there's not a very clear and concise way to write it, so I'm just going to begin writing the answer and explain as I go. And if you're looking back at your notes later, you probably will see the structure of it. So I noticed that this is a chain in a chain, chain in chain, and so my final answer is, okay, bear with me now. In the chain rule, I take the derivative of the outermost function and I leave all that stuff intact, okay? And then I multiply by the derivative of that inner stuff. Okay, let me say all this again. The derivative of this entire function will be, well, the derivative of the outer function with the inner stuff intact. Then I'll multiply by the derivative of this. Well, this is another chain rule. So I'll take the derivative of the outer function of this component with the inner function intact. And then I'll have to multiply by the derivative of the inner function. There we go. That's the super chain rule. You could make a fourth one if you wanted to, and it would get even longer. Okay, last problem is going to be the quotient rule. The biggest thing happening is the quotient rule, and I think it's fairly obvious. So we have the quotient rule, and in the process of doing that, we're going to have, I'm going to call them U's and V's again. I just think it's a little more convenient. Call the numerator, entire numerator U, and the entire denominator V. And I'm going to have to do something special in that numerator. We're going to have a little bit of chain going on in there. But first, let's write the quotient rule using U's and V's. So f prime g minus f g prime, all divided by g squared. I said one thing, wrote another, but I think you got the hang of it. And we are going to figure out everything that we possibly can. So let's write our final answer in purple once again. U prime, oh, that's sine of h of x. Oh, well, let's switch colors now. Knowing what u is, that sounds like bad grammar, but what u is. Here's what u is. And I need to know u prime, which involves chain rule. And the derivative of something that involves a chain rule is outer function, derivatized, not a word, with the inner function intact. And then we multiply by the derivative of the inner function. We'll put it in the front. There we go. That's it. So that, my friends, is u prime. I'm glad we're friends. I can talk about derivatives with you. That's what friends are for, right? Keep smiling, keep shining. I'll be on your side forevermore. It's an old song. That's what friends are for math times, calculus. Okay, I'm making it up now. There we go. I'm just, whoops. I just made a mistake. Hope you caught it. All right. It's subtle. It's just one little thing I need to put in there. I was so busy singing and making up lyrics to an old song that I messed up somewhere. And here's where I messed up. F prime G, or U prime V, minus U V prime. I forgot to take the derivative. Oops. All divided by V squared, so F of X, all squared. This is correct. Like, everything about it is right. I'm going to rewrite it again. And if you're thinking, why am I going to rewrite all that? This is fine. Totally good. But just mathematically, I don't like things hanging around after a trig function. It looks confusing. It's like cosine of h of x times f of x. Just put them in the front. That way we have our cosine last. No one's confused about what we're cosigning or signing. So here goes. One more. I'm going to put f of x in the front. H prime of x cosine h of x minus f prime of x sine h of x, all divided by f of x, all squared.